Last two vocab terms. First, we're going to look at what's called summation notation. You may also hear it referred to as sigma notation because this symbol right here, this E-looking symbol that I'm attempting to circle, is called sigma. It's a Greek letter. What that means is you add up all of the terms. The number at the bottom tells you which term to start with. So you would start, in this case, by substituting 1 in for I. I is called the index. And you would stop, the number at the top tells you which term to stop adding. And then you add all of those terms together to get your sum, which is an example of a series. A series is the sum of the terms in a sequence. So we're going to start by evaluating a factorial expression. We saw a little bit of how they worked with one of our sequences before, but this time what we're going to do is we're going to expand each of the factorials and then simplify as much as possible. What I do when I'm given something like this is I know that 6 factorial is part of 8 factorial because 8 factorial is 8 times 7 times 6 all the way down, and 6 factorial is 6 times 5 all the way down. So what I do is I just partially expand that 8 factorial until I get to 6 factorial, and then I can cancel that with my 6 factorial in the denominator. 2 factorial is 2 times 1. Of course, multiplying by 1 doesn't change anything, so I don't ever write that part down. So as you can see, we can cancel our 6 factorials. 8 divided by 2 is 4, and 4 times 7 is 28. Next, we're going to take a look at evaluating that sigma notation. So again, what this means is we replace I starting with 1, so we're going to find the first term through the 5th term, and we're going to add all of those terms together. So our first term would be 3 times 1, or 3. Our second term would be 3 times 2. Our third term is 3 times 3. Fourth term is 3 times 4. And our fifth term is 3 times 5. So when we add all of these terms together, we get a total of 45. And our final example, this one says give the third partial sum. So what that means, if you look at the sigma notation, it tells us to go from 1 to infinity. In a few days, we're going to see how to add a sum, an infinite sum. This one, it's just asking for the third partial sum, so that means through the third term. So we're going to find our first term, which is 3 over 10 to the first, plus our second term, which is 3 over 10 squared, or 100, plus our third term, which is 3 over 10 cubed, or 1,000, and we're going to add those together. First, we need a common denominator, so I'm going to multiply my first term by 100 over 100. I'm going to multiply my second term by 10 over 10. And of course, my third term has that common denominator. So when we add these all together, we get 333 1,000ths, or in decimal form, 333 thousandths. And everybody's favorite, your U-Try questions.